Well, now we have to go through another part of the kinematics. As earlier in the kinematics, we have discussed about the speed, the velocity, the concept of rest and motion, the uniform velocity, the variable velocity, their mathematical formulas, and now we are further continuing with the kinematics. And in this portion of the kinematics, we have to go through with the concept of acceleration. So what exactly is acceleration? How it is represented? What is the derivative method for representing acceleration? Basically, acceleration is the rate of change of velocity. So rate of change of velocity, that gives the value of acceleration. It is basically a vector quantity, and it can be positive or negative. If velocity is increasing, we say that the body is accelerating. If the velocity of the body is decreasing, we say that the body is retarding. That is, it will be decelerated. So, like in the definition, it is defined as the rate of change of velocity. It is a vector quantity, as I have explained you earlier, and then its direction is same as that of the change in velocity and not of the velocity. So direction of change in velocity matters, not simply velocity. There are three ways possible in which change in velocity can take place. Now, one of them is that when only direction changes. Like for example, a particle is moving in circular motion, we find that at every instant of time, the position of particle goes on changing on the circumference. So, whenever particle is at one position, at that point we draw a tangent. The direction of tangent represents the velocity, and if it goes to the next position, the direction of tangent changes. So, at that point, the velocity will be different as compared to the earlier one, and the change in velocity will be the change in direction of the tangent. Therefore, acceleration changes when only direction changes. The change the direction, net acceleration or net force should be perpendicular to the direction of velocity. Now, there is an example of it, that is uniform circular motion. As I have explained you just now, that in the uniform circular motion, the radius of the circle is not changing, but the position of particle on the circumference will be different and different instants of time. So velocities will change at the different instants of time because the direction is changing. Now, another thing, when only magnitude changes, like the magnitude of acceleration is given by taking the modulus of acceleration. In this case, net force or net acceleration should be parallel or anti-parallel to the direction of velocity, that is straight line motion. Now, the example will be when ball is thrown up under gravity. When the ball is going up, its velocity will go on decreasing, and at the highest point it will become zero. Similarly, when the body is coming down, its velocity is going on increasing, and finally when it will touch the ground, it must have some final velocity. So, when only magnitude changes, we find there will be variation in acceleration when both direction and magnitude changes. So now it is a case of both direction and magnitude. In this case, net force or net acceleration has two components. One of the component is parallel or anti-parallel, that is horizontal component, and another one is perpendicular to the velocity, that is the vertical component. So the example is projectile motion. When we throw a body, we'll find that for few movements it will move parallel to the earth, and finally it will bend towards the earth and will make a parabolic path. So in this case we find direction and magnitude both are changing. Now, types of acceleration. So we have to go through the various types of acceleration. Like one is instantaneous acceleration. When we use the term instantaneous, we are referring to acceleration at particular instant of time. So it is defined as the acceleration of the body at some particular instant. Now this can be expressed in terms of, that is, derivatives or limits. Delta V is indicating small change in velocity or small velocity. Delta T is small time. So delta V over delta T, small change in velocity. So we have taken a limit of this number, that is limit delta T approaching to 0, delta V over delta T, and that is equal to dV over dt. Now dV over dt means derivative of velocity with respect to time. That is, if we take the derivative of velocity, that will become acceleration. So instantaneous means at specific instant of time. Now we come towards the average acceleration. The definition is very similar to uniform velocity or uniform speed. Like uniform velocity means body covers equal distances in equal intervals of time. But in average acceleration, we find that first of all, in traveling from one point to the different points, we note the accelerations. Then all accelerations are vectorially added divided by the total time. So average acceleration AV is equal to delta V over delta T, and delta V is change in velocity, so it is V2 minus V1, and delta T is T2 minus T1. Now we come towards uniform acceleration. Uniform means that throughout the motion, acceleration is not changing. Such acceleration is called uniformly accelerated motion. So when the body is moving under the influence of uniform acceleration, it means that the body will be uniformly accelerated. Now, so one of the very important note is that if a particle is moving with uniform acceleration, then that does not necessarily imply that particle is moving in a straight line. So it is not very important that it should move only in straight line. Like for example, the projectile motion, we find the acceleration is uniform, but the projectile motion is not in straight line. Ultimately, it makes a parabolic path and then strikes the ground. Non-uniform acceleration. A body is said to have a non-uniform acceleration if magnitude or the direction or both direction and magnitude changes during the motion. So if magnitude and direction both will change, we will say it is a case of non-uniform acceleration. Now again, acceleration is a vector quantity and having dimension Lt minus 2. When we use the term acceleration, it is velocity over time. Velocity is Lt minus 1 divided by t, so the whole function will become Lt minus 2. This can also be written as m naught Lt minus 2, and SI unit is meter per second square. However, if acceleration is constant, then acceleration is uniform, but motion is non-uniform. And if acceleration is not constant, both motion and acceleration are non-uniform. Now we come towards the application here. If force F acts on a particle of mass m, then by Newton's law, we find that force is mass into acceleration, or A is equal to F over m. Acceleration is F over m. That is basically the second law of motion. Now, we are coming towards the application of derivative for defining acceleration. We have written here that V is equal to ds over dt. ds over dt means derivative of displacement with time, that is velocity. And then we have written A is equal to dv over dt. dv over dt means derivative of velocity with respect to time. So we can write d over dt, and for v, we can put ds over dt, and that will become d square s over dt square. D square does not mean that d is multiplied 2 times. It is a symbol of acceleration. So d square s over dt square is the double derivative of displacement. So what exactly we have seen in this point? That if we take the derivative of displacement, it will be velocity, and if we take the derivative of velocity, it will become acceleration, and the representation will be double derivative of displacement. If Displacement vector is given as a function of time. Second time derivative of displacement gives acceleration. As acceleration is acceleration's dv by dt, the slope of the velocity time graph gives acceleration, that is, acceleration is dv over dt, that is tan theta. So whenever we have to develop a concept of slope, slope means tangent of the angle. So on all the numbers, we have just given an arrows. That means we are referring to vector quantity. So acceleration is rate of change of velocity, and that is equal to tangent theta, and that is the slope of velocity time graph. In the next point, acceleration can be positive or negative. If velocity increases, acceleration will be positive, and if velocity decreases, the acceleration will be negative. So acceleration can be positive or negative. Positive acceleration means velocity is increasing with time, while negative acceleration means the retardation, and that means velocity is decreasing.